Okay, so we're gonna do statistics 101. I'll start with a land acknowledgement that we are all right now living and working on beautiful land that is known as Turtle Island, and that has traditional owners and custodians of that land, the first people of this land and Indigenous people. And we respect them as the custodians of this land. And personally, I'm very honored to have been born here, to live here, and raise my family here in Toronto, which is the traditional territories of the Anishinaabe, Haudenosaunee, Huron-Wendat, and Chippewa people, and covered by Treaty 13 with Mississaugas of the Credit First Nation. And this has been a long time coming, right? Stats 101. Who is doing a statistical analysis right now? And like a quantitative statistical analysis with a data set and potentially writing a conference abstract or paper with that. Okay, we have one in the room, and you can raise your hand online. You can see them, right? But I can't. Okay. Okay. And then, well, we're going to be using, and Farzan, and we're going to be using Farzan's data as a teaching point. Okay. If I can like get this to work. So we're going to go over again, my favorite thing in the world. Pico. Anybody else love Pico now? Nobody? No one has raised their hands? Okay.
I don't even remember what it stands for.
Okay, I'm going to go over it, of course. Okay. So we're going to go over quantitative statistical analysis. So when you do a statistics course, there's three components of the statistical analysis. The first one is what's called as the summary statistics. It's summarizing the data. Okay. So you have a data set, let's say of 200 study participants, and you can imagine like an Excel spreadsheet with each study participant like as a row, and then all the variables you're collecting like at the top, and you have data entries, quantitative data entry for each of those variables, like age, and then blood pressure, and then you could have, do they have diabetes? Yes or no? Have they had a cardiovascular event? When was the time of the cardiovascular event? That's all data, right? And you have it for each participant, but you're not going to show the table with 200 people with 200 variables. We summarize that in summary statistics. Okay. It's also known as descriptive statistics. I see people shaking their heads that you maybe took this in university. Okay. Then the second thing we do is we do comparator analyses, usually comparing two groups, could be three groups. So we compare one of those variables or all of those variables between two groups. That's comparative analysis. And then the third thing that we do is we spend a lot of time, if we find a statistical difference in that comparison, we spend a lot of time trying to assess if there's biases, or a lot of time eliminating biases. Okay. And we're going to talk about the ways that that's done. And biases become really important in the sense that, is that statistical difference? So people with diabetes have more cardiovascular events than people without diabetes. Is that statistical difference? Is it true? Or are there biases? And it's actually smoking that's more associated with the cardiovascular event. Okay? And so we're going to talk about that. So 3 things we do with statistical analyses. Does that make sense? And is that helpful to go over? Okay.
Yeah.
Okay, so again, I love Pico. So we are going to use Pico here, or Picot, but it's really in this setting, Pico. Maybe I'm not going to. No, it's okay. Yeah, let's see. So Pico stands for population, then the I is intervention or independent variable of interest, and then C is the comparison of that intervention or the independent variable of interest, O is the outcome, and T is the time. Okay, we do have an example. So this is Farzan's Pico. Okay, Farzan is using Chiwos data. Okay, so Farzan, I'm gonna the P for your population is not it's not immigrant women living with HIV. It's actually going to be all the Chiwos participants. Okay, so it's all the women living with HIV who participated in Chiwos. Okay?
Yes.
Yeah. Your immigrant status is actually your independent variable. Okay? Are they immigrants? And then there's lots of different things you can do with immigration as a independent variable or variable of interest. There's are they an immigrant? Yes or no? Then what kind of variable is immigrant? Yes or no? Who can tell me? Okay, it's a binary variable. You can do what type of immigrant are they? Right? Are they non-status? Are they refugee? Are they a landed immigrant? Are they Canadian citizen? Right? You can do, are they born in Canada, not born in Canada? You can look at duration since immigration. So do you see, Farzan, like it can get a bit more complicated in terms of, so you really have to like think of which variable you're really interested in terms of your intervention. Or it's really, in this case, it's an independent variable or exposure. So we use the term independent variable and exposure mean the same thing, or a predictor.
And so under the I, still like under the intervention.
Yeah.
It's like immigrant women.
Immigrant women, and then what's the comparison? What's the comparison to immigrant women? Non-immigrant women. So you take the population, Farzan, is the whole Chiwos population, and your independent variable of interest is the women who've immigrated, and your comparison group is the women who haven't immigrated, right?
What is a binary variable?
And we're going to go through it. Yeah. Okay. And then your outcome is disclosure, right? That's what you're interested in.
Yes.
Disclosure concerns.
Concerns, yeah.
Okay. And in Chiwos, that's a scale. It has a scale. And it's reported 0 to 100, 100 being more disclosure worry. And so you can see that we're just going to remove the T at this point. But you said you were interested in duration since immigration, less than 1 year, 1 to 3 years, greater than 3 years. Okay, actually, yeah, if you wanted to do, if that's what interests you, then the duration of immigration actually becomes your independent variable, and you can do immigrant women as your population. So there's like lots of different things you can do. Do you see what I mean? But you have to be very clear on what your population is, what your independent variable of interest is, what your outcome is. The outcome are the clearest on, right? Because we're worried, we want to know disclosure worries. And let's just leave out the T. So the T is often only used in clinical trials. So PICO is used for systematic reviews and for most other studies. Okay, but I like the T too. The T is at the time point that your outcome is measured at. This analysis is cross-sectional. So there's really technically no T because it's cross-sectional. Okay. Okay, so now we're going to use that as an example. I often think about how when it comes to statistical analysis, really knowing what your outcome is, in terms of what outcome you're interested in as your variable is probably one of the most important things. It's very easy in Farzani's case because Farzani's outcome, we clearly know what she's interested in. It's HIV disclosure worries, right? So let's think about that variable. It's a scale with 5 questions, and it's a Likert scale, and each question gets scored from 0 to 5. Okay, so then you can see people can have 0, or they can have up to 25, right? And then what we do is we convert that score to 100. We just multiply it by 4. Okay, and then you can do things like you have to define, like, what if a participant doesn't answer one of the 5 questions, right? What do you do with that result, right? So so you have to like make decisions about that. So what we often will do is if participants answered more than 50% of a scales question, we will like apply the median of or the mean of the other answers to the score. It actually ends up being the same because you're just taking the 3 and making the average, and then we convert all the scores to 100. Okay. One important thing about considering your outcome is there's usually, you should think about one outcome. There's one outcome in quantitative analysis. If you want to look at another outcome, then that becomes like a second, that's like a second PICO. Do you see what I mean? Because there's only one outcome per PICO. Okay. And then what are the different kinds of outcome variables typically? What is disclosure? This disclosure worry.
And that's the Likert scale.
Yeah.
So would that be ordinal?
So it's actually, it's a continuous variable because it goes from 0 to 100. Okay. Yeah. So it's a continuous variable that that the higher the score, but like technically it can only go in like categories of 5s. Right?
And it's because you're multiplying it to get the 100 total.
Yeah. Like we could leave it at 25 and yeah, it would be but it's a continuous variable. Yeah. Now, so can you give me other examples of continuous variables? Weight, age, height. Yeah. So you see like they're numbers and they're continuous, right? Okay. Now, what we often do is we take continuous variables and we actually convert them to potentially ordinal variables or categorical variables. And the most common categorical variable we use is a dichotomous variable, or someone said binary, is like a yes, no. Okay. So we can take the disclosure worry as a continuous variable. And we could make it a dichotomous variable. Okay, and that's actually what we've done for Farzani's analysis, which is, and what we did is we took the median and we divided high disclosure worries are above the median and low disclosure worries are below the median. So very often we take a continuous variable and we convert it into a dichotomous variable. Okay, what other dichotomous variables could do you see potentially being used, or if anybody else has an analysis that they're doing?
For mine, we have like, if they face childhood violence or didn't face childhood violence.
Yeah. So, but that's the independent variable,
Mhm.
right? And what's your outcome?
If they face adulthood violence or didn't face adulthood violence.
Okay. Okay, so that's a dichotomous variable. Yes, there you go. Okay. So it's really nice to use dichotomous variables because they're so easy to comprehend, right? So we love dichotomous variables. But we do something called sample size calculations. And when you use dichotomous variables, it lowers like what's called the power, and you need much higher sample size calculations
Where to go?
to analyze dichotomous variables. And also you want your sort of the group to sort of have 50% didn't have it and 50% have it. If like 95%, like I'll give you an example. In CHIWOS, the participants of CHIWOS, 90% of them had high resilience. So then as a dichotomous variable of high resilience versus low resilience, the only difference you're actually working with is that 10%. So you can see like to look at who has high resilience versus low resilience, your power goes down because the power is driven by that 10% difference. So something like disclosure worries, which was about the median score was about 60. You can see it's like it's sort of half and half. So it becomes, and then actually that's why we choose the median. Who knows what the median is? Right, but the median is the 50th percentile. So we take the 200 participants and we line up all their answers in a row. And number 100 is the median, okay? And then that's different than the mean, where we add up all the values and we divide it by 200, okay? So that's why we choose, when we convert a continuous variable to a categorical variable, if it makes clinical sense, then choosing the median is helpful because half your population is high and half your population is low. So we're kind of forcing the best power. Do you see that? Okay. Now, can we change disclosure worries, which is a continuous variable, to an ordinal variable? What's an ordinal variable? You brought it up, so.
Like something like education level, something that has like a very strict number of options kind of.
Yes, ordinal is education level, but it's increasing. Categorical variable, you can have a categorical variable where they're unrelated. So what's your favorite color? So what's your favorite color? What's your favorite color?
Green.
Purple. So there's 2 purples, 3 blues, 1 green, 1 pink, right? So that's categorical, right? And then what you would do, those are the counts. And then 1, 2, 3, 7, we would, 3 out of 7, and you'd get the percentage of the proportion of people who blue is their favorite color. That's categorical. Ordinal is, yes, you have a below primary school education, primary school education, high school education, university education. But what you can do is you could take your continuous variable and rather than just dichotomizing it, you could have 3 categories, right? You could have a high disclosure worries, medium disclosure worries, low disclosure worries. So that's become ordinal or 3 separate categories, but there's an order to them. Okay. I know I'm spending a lot of time like talking about like the different types of variables, but you're going to see why.
It's helpful.
Yeah, okay. Now there's lots of different types of variables that we're not going to talk about. So the main variables we're going to talk about are continuous variables and categorical variables. And the easiest way to think of categorical variables are like a dichotomous variable. Yes, no. Okay, that's like the classic categorical variable. Is everyone clear on what a continuous variable is and what a categorical variable is? And I'm going to say actually categorical variable because that's actually the correct term. But when I say categorical variable in your head, think of a dichotomous, think of your variable that you're thinking of as dichotomous, like high disclosure worries, low disclosure worries. Okay. But there's lots of other types of variables that analyses are done with. You can do economics as a variable type. Did you know that? It becomes a dollar amount. There's something called a QALY. So it's a, what's that?
Quality, it's a fun name.
Yeah, QALY. I can't remember what it stands for. Oh my goodness. So maybe someone can look it up. But that's a type of economic variable.
Quality adjusted life year.
Quality adjusted life year. And if you can imagine, the Ministry of Health has a dollar amount per QALY increased. So it's the dollar amount per 1 point increase of quality of life. And if an intervention is over, I can't remember whether it's $20,000 or $40,000 per QALY, it's not cost effective to do that intervention in Ontario or Canada. There's a dollar amount to
They assign that.
if that stuff interests you, that's health economics.
Sorry, what does QALY mean again? Stand for?
Quality adjusted life year.
Quality adjusted life years.
Thank you.
So it's the dollar amount per increase in your quality adjusted life year. Okay. And what does that mean? A quality adjusted life year? That is, if your life is extended by 1 year at 100% quality of life, what's that quality? It's a utility. What utility is that? 1 year. And like if you die, what's the quality? What's the utility? 0. And then with every disease state, there's a utility assignment. Okay. So somebody with, like, I have osteoarthritis and I had a knee replacement. So my utility, like my quality of life is not 1. My quality of life is like, let's say 0.9. Okay. Someone with rheumatoid arthritis, a lot of inflammation, their quality of life is 0.7. Do you see that? And so, and then a quality adjusted life years is the dollar amount to increase that utility by 1. Okay, so that's economics. If that interests anybody, lots of jobs in that area. Okay. Another type of variable is a time to event. Okay, and oncology, so cancer trials usually use this variable. A time to event is like survival time. So for cancer treatment, what is the survival time? And it's kind of like morbid because it's technically it's time to death, right? So but that they measure time. Okay. So continuous variables in, like, for example, the disclosure worry is a continuous variable. CD4 count is a continuous variable. HIV viral load is a continuous variable, right? And so even let's think about disclosure worries, 0 to 100, okay? We will summarize that using we will still summarize disclosure worries as we'll still summarize it with its I'm trying to look for it here. I have it. Okay. We'll still, so now this is the part, the first component of statistical analysis is the summary statistics. So you're going to take your outcome and you're going to do the summary statistics of that outcome. If it's a continuous variable, it is summarized using a mean and a standard deviation. Only if your continuous variable is what? Does anybody know? Normally distributed. Okay. So like where the cases all go like this. And so, and does everybody know how we calculate the mean? Right? We add up all the disclosure worries and we divide them by the number of participants. Okay. If you don't know if your data is normally distributed, which means it's like the average, like a bell curve. Yeah, thank you. It's always better to report it as median and interquartile range. So my preference is to use median and interquartile range as the summary statistic. This is the summary statistic for a continuous variable. And basically, again, you line up all the answers and the median is what we call the 50th percentile. And when you report a median, you always have to report the 25th percentile and the 75th percentile, or you present the range, but 25th and 75th is probably better because then you're not actually with the range, you're potentially age, you're potentially disclosing personal health information. If you do report mean, you have to report it with a standard deviation. Okay. I'm just telling you this because one of my pet peeves is seeing conference abstracts without, like you report a median and with no interquartile range. It's called like 25th and 75th percentile, or a mean without a standard deviation. It like they almost mean nothing without that context. Okay. So for Farzani's case, disclosure worries had a median. I was gonna do switchy, like, but it cost too much trouble and show you, of 60. So I was right, 60. And the 25th percentile and 75th percentile, and saying 25th percentile and 75th percentile is synonymous with interquartile range. Those mean the same things, okay? The interquartile range is the 75th and is 40 and 75. So that means that 50% of the people have a disclosure worry score between 40 and 75, and then the rest have above 75, and then the rest below 40. Okay, and then the median, I mean the mean is 58.8 with a standard deviation of 24.9. Okay, so do you think the values are normally distributed? Or in which way are they skewed? To increase disclosure worries. But it's like 58.8 is like 59 and 60. It's actually pretty good. They're pretty normally distributed. Okay. So that's just like an example. A categorical variable is like, let's say gender, 'cause like, and you know, gender is difficult because we put it as a categorical variable, but do we want it as a categorical variable? But often we'll put cisgender, trans, non-binary, gender diverse, gender queer, two-spirit. I really like the favorite color, right? So, and what you would do is categorical variables are summarized using frequencies and proportions. And what that means is the frequency is the count, and then the proportion is that divided by the denominator. So in our case, it was 3 people blue. And what's 3 divided by 7? It's about like 45%. 40%. Can someone do it? So as a categorical variable, it's
43.
43. I think there's a question. Can somebody?
So I'm just at 40.
Oh, 43. Okay, great. Thank you. So categorical variables are summarized by frequencies and proportions. That's what we say. Okay. Why I'm kind of going over this is I'm going to explain to you in the analysis section of your paper, what you're going to write is socio-demographic variables and outcomes are summarized using medians and interquartile ranges for categorical variables and frequencies and proportions for categorical variables. Did I say that right? Continuous variables. Okay. So socio-demographic variables and outcome variables are summarized using median and interquartile ranges for continuous variables and frequencies and proportions for categorical variables. Do you see that? Okay. Okay. I know what I can do. Okay. Okay. So again, the mean is also known as the average. Is you add up all the numbers and you divide by how many there are. Median, you order from smallest to biggest, and you take the middle value. And the mode, oh, I forgot about the mode.
The most.
Yeah, the most occurring outcome.
So like favorite color would be blue.
Blue, yeah, and it's also the mode.
Yeah, for the mode, right?
Yeah. But I think these are just for continuous variables.
Okay.
Mode, mean, median, mode is just for continuous variables.
So just numerical.
Just numerical, yeah. Okay, now we're finished with what we use statistical analysis for summary statistics. Okay, the second thing we use it for is comparisons. And we're just going to pick 2 groups. And for continuous variables, when you're comparing 2 groups, the test we use is the t-test. But the t-test can only be used if the sample is normally distributed and we're comparing means, okay? Otherwise, if you're comparing medians, the statistical test comparing the 2 is called Wilcoxon rank sum. So which one do you think I like? Wilcoxon rank sum, because it's comparing the medians. Okay. Okay. And then for comparison of proportions, okay, so the 43%, let's say the blue lovers versus the non-blue lovers, right? Like we're going to dichotomize the variable, this categorical variable, 43% versus 57%, right? Those are proportions. Do you see that? what test do we use to compare proportions?
Chi-square.
Chi-square test, yes. Now, the chi-square test is an approximate. If you have very small sample sizes, like in this analysis of a sample of 7, we actually use a test called the Fisher exact test. And it actually, like, it's done manually to calculate the difference. Which one do you think I prefer? I prefer Fisher exact. I like exactness. You didn't know that? Yeah. Okay, but chi-square is much easier to do, okay? So the reason this becomes important is in that sentence of your statistical analysis, the phrase, this is how the phrase goes. It goes, sociodemographic and outcome variables were summarized using median and interquartile ranges for continuous variables and frequencies and proportions for categorical variables, and were compared using Wilcoxon rank sum test and chi-square test respectively. Okay, that's how they're compared. Do you see that? Okay. And then we set what's called a p-value. When you do those comparisons, you have the probability of that the observations that you are seeing is the probability of the observed outcome of the difference between the two groups is real. We arbitrarily set that if the p-value, it calculates a p-value. If the p-value is less than 0.5, then that's statistically significant. It's like arbitrary. And it corresponds to a 1 in 20 chance that if it calls a difference, it's wrong. There isn't really a true difference there. Okay. And so the way to think of it, the closer the p-value is to 0, the more statistically significant the result. So it's if you repeat the same research question with, so let's take Farzani's research question, and let's say, what do you think her finding is? Do you think immigrant women have higher disclosure worries than non-immigrant women? Or yes or no? Yes. And do you think it's statistically significant? Yes. Okay, let's say it's 0.04, the p-value. If you do exactly the same study in England, then, and you repeat the study 100 times, there's a chance, there's 5 out of 100, 1 in 20, that actually 0.4 is 4 out of 100, right? So 1 out of 25, that's not true. Okay, if it's 0.01, it's 1 out of 100, I guess, right? So you can see how if you repeat it. Okay. Okay. Very simple, right? I hope this is helpful for people, that we've gone over summary statistics, how we summarize continuous variables, how we summarize categorical variables, and then what tests we use to compare that type of variable between the groups, right? I'm going to Wilcoxon rank sum for continuous variables by comparing the medians, and Fisher exact test or chi-square for categorical variables. Okay. Okay. We're 2/3 of the way done. Isn't this fantastic? Okay. The third part, actually what statisticians spend all their time doing is trying to eliminate bias. Okay. So remember, the outcome, the other term for outcome is the dependent variable. because that's the one we don't control, right? We're not like arbitrarily dividing it. Well, actually we are. We divide it into low and high, but it's like the outcome, the dependent variable. And then immigration status is the independent variable, okay? And I know it's really confusing. I don't know what term you like, but the terms, independent variables have other words also as a correlate, risk factor. I don't like that term. Predictor, but predictor is not good because it implies causation, but you might hear that term. If you take a statistical course, it's called exposure. Do you know that? Who's taken a statistical course and knows that? Do you know that? It's called an exposure. Okay, like smoking, you're exposed to smoking, exposure, and smoking is associated with lung cancer. Okay, okay. Then we spend our whole time trying to rule out and eliminate bias, and in statistical language, that is called a confounder. What is a confounder? What's the definition of a confounder? Okay. A confounder is an extraneous variable in statistics that correlates both with the dependent variable or outcome and the independent variable, the exposure. And that the perceived relationship between the independent variable and the dependent variable, like you saw a statistical difference, but it's not really due to that independent variable. It's been misestimated and due to the failure to account for a confounding factor and in terms of a spurious relationship, that the independent variable and dependent variable relationship is spurious, and really it's due to the confounding variable, and the confounding variable is associated with both. And it leads to misestimation. So for example, in the early lung cancer studies, they found that having yellow fingers was associated with lung cancer. Okay, is that would that association be statistically significant? They did a case control study. It was statistically significant, right? But there's a confounder. What's the confounder?
Smoking turns your fingers yellow?
Yes, smoking turns your fingers yellow and it's associated with lung cancer. So the association between yellow fingers and lung cancer is spurious, and the true association is with smoking. And then there's techniques to look at associations and potentially prove causation. But those are the types of analysis that the cigarette companies did to prove that, to try to disprove that smoking caused lung cancer. Okay. Again, much of statistics is spent determining if our results are true and eliminating confounding. And so if you do, who's done a master's? I did one, I forgot. Did you use quantitative data? Yeah, okay. So if you do a master's, the majority of your master will be, you're going to do the summary statistics, right? You're going to do your comparisons, but the majority of your analysis and your time doing a master's will be doing methods and defending that difference was true and using different methods for handling confounding. And in your question period, half of your questions are going to be about handling confounding. Was that your experience?
Yeah, for the most part, it's all
Yes.
about the methods.
Okay. And so what did you use for handling confounding?
For we did the randomized control trials and
Did you do randomized control trial yours? Yeah. Okay. Okay. So here are the different methods of handling confounding. Okay. The gold standard is a randomized control trial. And why does it handle what does a randomized control trial do? We talked about this in the first session.
It randomizes the biases to each group, so it's not like they're all in one.
Right. So you have your population and you randomize them to your independent variable of interest, which is like an intervention. So an intervention versus a comparator, right? But for everything else, all the other variables like age, smoking, diabetes, high blood pressure, it's supposed to randomize them. And it randomizes known variables, known confounders, like the ones I just listed, but it also equalizes unknown confounders. So that's why doing a randomized controlled trial is the gold standard of handling confounding. But also why you can only answer one research question. Because if you try to answer another one, there could be biases. Do you see that? Okay. Stratification is another one. And sometimes we stratify within randomized controlled trials. So stratification could mean, for example, in a randomized controlled trial, we are going to stratify by sex. And because we want to over-enroll, female sex. So it's kind of almost like it's like two randomized controlled trials within a randomized controlled trial, because you're assigning, we want 50% of the participants to be female sex, 50% to be male sex. So and so it's kind of like two mini randomized controlled trials. But you can that's called stratification. Okay. Randomized controlled trials are often stratified, and you would use stratification as your method of handling confounding if you knew a variable was so important for the outcome. So one might be smoking for lung cancer, or like diabetes for cardiovascular disease. Okay. So let's say, for example, we wanted to ask the question, is vitamin D deficiency associated with lung cancer? Now, smoking is so important, a variable, that what you might do is stratify by smoking, so that you would make sure that you have equal amounts. Because it is possible you could do a randomized controlled trial and then design, and just by accident, you end up with more smokers in one group than the other, because randomization is not perfect. Okay, so that's stratification. We often stratify also by sites, by country for randomized controlled trial. But the big thing method we use for handling confounding is called regression modeling. Okay. And so this is where it all comes together. This is like the part I love. Are you ready? Okay. The type of regression model you use depends on the type of variable your outcome is. So it all fits together. The summary statistic of your type of variable is, median and interquartile ranges for continuous variables. Let's just say chi-square, because that's what's typically done. Chi-square for categorical variables. Frequencies and proportions for categorical variables. Wilcoxon rank sum for continuous variables is used for comparison. Chi-square for categorical variables. Okay. And so then the type of regression analysis you use also comes down to what type of variable your outcome is. If your variable is a continuous variable, you use something called linear regression. If your variable is a binary variable, you use logistic regression. If your variable is a time to event, like the ones we spoke about in the oncology trials, it's called Cox regression. And then there's even more if you want me to go on. Like if it's a rate, it's Poisson. If you've heard of Poisson regression. So all of the different types of regression are based on what type of variable your outcome is. And so then what you can do, let's pick logistic regression. That's the most typical one done, like for example, in a master's, because it's a binary outcome. So with Farzani's case, it's high disclosure worries versus low disclosure worries. That's the outcome. It's binary, right? Because we've converted it to a binary variable. So which regression analysis are we going to use? Logistic. Okay. Now we could keep Farzani's outcome as a continuous variable, right? And which one would we use? Which regression?
Linear.
Right. So, okay.
What about ordinal?
There is, I don't know. Ask ChatGPT or something. What regression analysis do you use for ordinal variable or ordinal outcome? Okay. So logistic regression is the easiest one to figure out.
Ordinal logistic regression.
Okay, great. There you go, easy. So maybe like logistic regression is just for categorical variables. So then, you remember when we were talking about for a binary variable or, we summarize it with frequency and proportion, and we compare it with chi-square, right? And you measure something called like, there's like the amount that there's like an association, like the p-value, right? That's like how significant it is, but you actually measure like a relative risk or a relative ratio of how much this one group has more than the other group, right? So how much do women who are immigrants, how much more disclosure worry do they have than women who are non-immigrants? So let's say it's like 2 times more. We actually we measure that amount, okay? And that comparison, if you do a logistic regression with the one variable of interest, okay, with immigrant status, okay, the result is the same as the regular comparison in chi-square. But what you can do in a regression analysis is you can add in other variables, age, province that you were recruited in, rural versus non-rural, duration of immigration. So you can add in all those variables, and then in logistic regression, the comparison value is called an odds ratio. So you're comparing the odds, and then that odds ratio ends up being adjusted. It's an when it's just the one variable, it's an unadjusted odds ratio. And then if you add in other variables, it becomes the adjusted odds ratio. Do you get it? I find linear regression, if you can do logistic regression, it's easier to understand because it's like the odds that a woman who immigrated has higher disclosure worries is 2. So that means 2 to 1 is the odds, versus women who weren't immigrant women. It's easier to understand. With linear regression, you get something like called a coefficient. So like it would be something like each age has a higher increase in height per year of 10 centimeters, but then you have to like interpret that. So it would be like immigrant women versus non-immigrant women have an increase of their score of 5. Do you see what I mean? Like that's what it would end up being, which we could do. Okay. And then here, let's say, this is like, we often will take viral load as an outcome at 48 weeks after being on a new HIV treatment, and is it undetectable? And okay, and you get an odds ratio. And you report your odds ratio with a 95% confidence interval and a p-value. Cox regression, or also known as proportional hazard, is a time to event, and it reports what's called a hazard ratio. And then univariant analysis in regression is when you only have one covariant in your model, and that's like your independent variable of interest, but you report actually like the odds ratio of all the variables. And then in univariant, and then you also report them in multivariant, and you choose what variables you want to put in your multivariable analysis. And then you spend a lot of time in your masters proving why you chose that way of building your multivariable analysis. So what variables did you choose? Because you can't just put all of them, but you can. And that is called a, oh, it's going to bother me. I think parsimonious. I think that's what it's called. You can parsimonious regression analysis, where you put in all of the, I think that's what it's called, variables.
Yeah.
So you can do that. You could just put in all the variables, and that's called a parsimonious. Regression analysis, you can double check that.
Yeah.
It
says
is?
that it
Yeah. And then, but then you can choose your variables that you want to put in your regression analysis just based on clinical importance. So that's a way. And then sometimes we do something called forward and backward selection of the variables in the regression analysis, where we choose the ones that are significant at 0.01, and we put those in, and we add them or remove them until you get the best fit of the model. Okay. So who's done social work or sociology? Okay. So who's planning to do something like that?
I might do social work.
Yes, okay. So in like, I studied like quantitative methods. And so we are of, the framework as positivist. Do you know what that means? Positivist, like scientific frameworks. And then people in social work are considered post-positivists. You've heard of that? No? What do we use in WHRP, Women, HIV and Health Research Program? What are the frameworks we use?
Intersectional feminism.
Okay, yeah. What else?
Anti-oppression.
Anti-oppression, anti-racism. Yeah,
CPR.
Informed care.
yeah. So those are all post-positivists. Okay. Frameworks of looking at how you're doing your analysis. Technically, quantitative analysis has the concept that there's a truth. Positivist theory is that we're doing science to find out the truth. And so that's why we're doing all this regression analysis. Are these really associated? Is it the truth? And, but if you don't find a statistical difference, it doesn't mean that that what you found is true or not, right? It might be that you had an insufficient sample size, or you didn't ask it in the right population. It doesn't mean that even if it's not statistically significant, that it isn't important for some of the people in the group, right? And then sometimes like we do continuous variable, and the disclosure worry difference is 0.25, but it's statistically significant. So that might not be clinically or socially significant. It could be statistically significant, but it's not clinically and socially significant. And then if you do repeated analysis, like if you look over and over and over again, just because of chance, that 5 out of 100 times, you're going to find a statistical difference just by chance, spuriously. That it's like data dredging. So you will find differences. Okay. So you always have to take your statistical analysis in that context of that, like, you have to think about the clinical significance and have you really ruled out all the confounding, and are you doing data dredging and too many comparisons? And then doing work in this field and having people like Carmen Logie and Wangari throughout teach me that often there isn't one truth, right? So, and moving to post-positivist and using those post-positivist theories and decolonizing theories in quantitative data analysis becomes interesting. So for Angie, for example, there is decolonizing quantitative analysis books. So, okay. And then some of the points we haven't gone through is, so if you take a statistics course, you're going to spend time doing your summary statistics, right? We went over that. What test you use for comparisons. You're going to go over regression. And what we didn't go over is you would go over in a first year statistics course, how to use all of that to do a sample size calculation. We're not going to go over that today, but just so that you know that. Also, for your other points to consider, when you doing your statistical analysis and you find an answer, right, your odds ratio, it's technically only for the population that you studied. And can you make conclusions for all women living with HIV in Canada or the world? So you have to ask questions like, was your population generalizable? And how much can you generalize your finding? Is there biologic rationale? Is there clinical rationale? Is it clinically significant? Was it an appropriate study design? Adequate presentation of data? And what do you do on how do you handle missing data? So we went over that a little bit. So we have high disclosure worries. We have the result for the entire sample. And then we have, but let's just forget the first column, I think. And then we have those with high disclosure worries in the second column, and then those with low disclosure worries in the third column, and then the p-value, okay? So let's look at high disclosure worry column, this one. Do you see that? Okay. In British Columbia, 40% of the women had high disclosure worries, while in Ontario, it was 56%, and in Quebec, 60%. And the p-value is less than 0.001, okay? So what kind of variable is this? British Columbia versus Ontario versus Quebec? Categorical variable. And what summary statistics were used? Frequency and proportions. And what comparison test? It's categorical, so it's chi-square. Yeah, okay. And then let's look at this. I thought this was interesting. Small city, 52%, medium city, 50%, large city, 54%, with no statistical difference. I would have thought there would be a statistical difference, wouldn't you? So that's like the thing, like you have your hypotheses. That's why it's actually important to come up with your hypotheses before, because like that's kind of like surprising, right? Okay, here's age. So those with high disclosure worries had a median age of 41, and with low disclosure worries, 45. So those who are younger had more disclosure worries. Isn't that interesting? Yeah, and this would be an ordinal variable, right? Do you see that? Age, increasing age, okay? Okay, and then we have ethnicity. 43% of Indigenous women had high disclosure worries. 76.5% of Black women had high disclosure worries. And 42%, we have to change the Caucasian, we typically use white now, had high disclosure worries, 53% of other ethnicities, statistically significant. And then this is what Farzani is interested in, which is foreign-born women, 71% had high disclosure worries versus Canadian-born women, 43%. Length of time living in Canada for foreign-born, so you can see that the longer, so 12 years median number of years for low disclosure worries versus 8 years for high disclosure worries. So, and then immigration status, 82.5% of women who were refugees had high disclosure worries. And so you would think, so this is like this is just like an example. So don't like take this anyway, but immigration status, you cannot, it's not an ordinal variable. It's not like, there's not one higher than the other. It is a categorical variable. That is often a mistake. Very important not to take certain variables, and convert and think that they're ordinal variables when
Implies like progression.
right.
Yeah.
Yes. Okay. That's
Makes sense.
okay. They're categorical variables. Food security. Women who were food secure, 46% disclosure worries. Women who were food insecure, 57%.